Assalamualaikum and a good day. My name is Siti Norazila binti Pazi. So this is final year project presentation. My title is Flame Retardant Behavior of Carbon Fiber Reinforced Geopolymer Composite for Heat Insulating Rocket Motors. So rocket propellants need a high thermal property insulator. So from this cross section we can see that there is one layer of insulations that was covered the rocket motor propellant. This is because the temperature can reach up to 2100 to 3100 Kelvin. During past developments, the insulator made of films and unfilled plastic or polymer, such as epoxy resin, phenolic resin, high temperature melamine formaldehyde coating. So the other types of insulator also made of polyester resin, ceramics, rubbers, and elastomer. The geopolymer composite uses a geopolymer as the binder. The geopolymer is an organic polymer. It is used source material for the formations of the geopolymer, for example, clay, kaolins, industrial products like slag and fly ash. It provides silicones and aluminium. This material will undergo polymerization when mixed with an alkaline activated solutions. The mechanical properties of clay-based geopolymer are they were fire and retardant and termite resistant, stable at temperature up to 1000 to 2000 degrees Celsius, and it has low density where it cannot increase the width of the propellant. So this project will be focusing on the fabrications of composite that embedded with geopolymer for rocket insulated coating, where the composite should be able to withstand high temperature produced by the propellant. So this is the problem statement. So the material was fabricated because of few things. The rocket propellants are plugged during takeoff, where it will distort the performance of the rocket. Then, the current insulator cannot withstand the high temperature produced. For example, insulator made of plastic cannot tend to crack and blister easily. The next is lots of research on current material. For example, the ability properties of elastomer is not sufficient enough in high velocity environment during the motor operation. So the objective is to investigate the thermal degradation properties of carbon reinforced fiber geopolymer composite using carbon fiber, to analyze the fire resistant behavior of fiber reinforced geopolymer composite, and to investigate the morphology behavior of the fiber reinforced geopolymer composite before and after fire testing. So this is the material that have been used, which is carbon fiber, hydrophobic kaolin, potassium hydroxide, nanoclay, and also potassium silicate. So this is the flowchart of the overall process. So we start with weighing the kaolin, silicate, and alkaline. So then we mix the kaolin with an alkaline solution using mechanical stirrer at 1000 rpm for 2 hours. Then we perform the head layout using different number of layers, where we vary into 1 and 2 layers. Then the samples undergo curing treatment using universal oven at 100 degrees Celsius for 2 hours, and then undergo fire retardant testing using UL94 EVH chamber. And then if the sample fail, then we fabricate another sample. If no, we start to record the data and analyzing. Degrees Celsius for 2 hours, and then undergo fire retardant testing using UL94 EVH chamber. And then if the sample fail, then we fabricate another sample. If no, we start to record the data and analyzing. So this is a few diagrams that show the methodology during the process. So this is where we stir the geopolymer using a mechanical stirrer at 1000 rpm for 2 hours. Then this is the process of applying geopolymer on an aluminum plate. So then here is after the first, this is the versions of the geopolymer composite, where we have 6 samples. The sample was varied according to weight percent of nanoclay. Then we vary the numbers of layers, which is 1 and 2. The width of kaolin and width of nanoclay was varied due to weight percent of nanoclay. So this is testing and analyzing. So we have fire retardant testing using UL94 EVH chamber, And this is the setup for the testing, which is we put the sample at the holders and the fire source was placed 1 cm from the sample. So the purpose of this setting is to study the fire retardant properties of the sample. So this is observing sample morphology behavior using Olympus microscope, where we observe the morphology behavior of the sample before and after the fire retardant testing. So this is result and discussion. So this is tabulated data where we collect all the sample, the visual observation before and after the testing. So there is char effect for all sample at the starting points of the sample after the sample were exposed to a flame for 30 seconds. At the end of the testing, all sample does not burn as the carbon fiber exhibit fire resistance and the geopolymer itself is not flammable binder. Same as for one layer, but the char effects for 2-layer sample is less denser than 1 layer. After 30 seconds of burn time, the sample with 0% of nanonuclei shows more clearer black char effect due to the burning. As the weight percent of nanonuclei increase, the char effect showed less color. The additions of nanonuclei help to slow the rates of burning of carbon fiber, geopolymer composite. Without the additions of nanonuclei, the fire from the burner directly reacts to the sample. Therefore, it will take some time for the geopolymer composite added with nanonuclei to burn. So, apart from that, the carbon fiber has high thermal resistance, where the inclusions of more carbon fiber can reduce heat transfer. It also can be seen here that there is a line of cracking after the testing. Now we continue with 1 layer with 1% of nanonuclei. The surface of the geopolymer composite shows shrinkage because the water was evaporated. So after the fire retardant testing, it can be seen that the sample agglomerated since there is 1% of inclusions of nanonuclei. So the agglomeration helped to reduce the effect of char because it takes longer time to burn compared to sample with 0% of nanonuclei. The next one is 1 layer with 3% of nanonuclei. You can see that a smooth surface with lower porosity can be seen at the sample before it was tested. After it had been exposed for 30 seconds, the sample does not burn, and it can be seen that agglomeration process took place. The water absorption reduction increased as the amounts of nanonuclei added increase. This is for 2-layer sample with 0% of nanonuclei. So this sample looked smooth before the fire retardants, and there are some crackings after the testing. So this is 2-layer with 1% of nanonuclei, and this is 2-layer with 3% of nanonuclei. Before that, we can conclude that the additions of carbon fiber will show less effect to the sample as it has high thermal resistance. The fire retardant, so we have reached the conclusion. So fire retardant in this project means that the material not be badly affected when it was exposed to fire, such as melting and damaging. For fire retardant testing conducted, it has been found that the optimal weight percent of knowledge is 3% as it showed the lesser black char effect for 1 and 2 layers of carbon fiber in first geopolymer composite. All the samples did not fail when exposed to fire during fire retardant testing using UL 94 AVH chamber according to ASTM D5025. All sample does not melt and does not show any damage effect. However, sample with 0% of nanonuclei and 1 layer of carbon fiber shows a huge difference when there is denser black char effect at the sample. Carbon fiber composite does not experience fire burning penetration, which strongly imply the improvements of fire retardancy properties by the presence of geopolymer that bind the carbon fiber. So in conclusion, the fire retardant properties of this geopolymer composite fabricated was supported by inclusions of fibers and the additions of nanoclay that improve the properties of the geopolymer. So what have been recommended from this research project was it should a fire task according to ISO 2685 should be conducted, which is it is an aircraft environment test procedure for airborne equipment with analyzing the fire resistant properties in designated fire zone. So the next one is a performing thermogrammetry analysis (TGA), which is a testing to measure weight loss of the sample after it has been exposed to fire. So this is to the purpose of this analysis is to determine whether the sample damaged by the fire test or not, as the damage could not easily observe with naked eyes. So I think that's all from me. Thank you.